So we want to begin a new unit on recursive sequences. So I am going to reintroduce recursive sequences from section 5.3. Section 5.3 does a bit of recursion. And in that section they have a good bit on recursive sequences. So let's look at parts of section 5.3. So first of all, we want to define what is a sequence. So what is a sequence? So when you're in Calculus 2, you study sequences and series. A big deal is series in Calculus 2. Maybe you remember a sequence is a function whose inputs are, usually you say positive integers, but we're going to say non-negative integers. So a sequence is a function whose inputs are non-negative integers. So counting numbers that start with 0 typically and that go up. So it could start with 1, it could start with 2, but typically you're going to start at 0, non-negative integers. So your first input would be 0, then 1, then 2, then 3, and so on and so forth. So you're not going to be plugging in any decimals into your function. So let's look at a quick example. Of just a sequence. Let's say 1 fn equals 2n minus 1. So the inputs are only going to be integers greater than or equal to 0. So there on the side, when I say n is greater than or equal to 0, that's telling me my domain. So I could plug in 0, for example. When I plug in 0, I have what? 2 times 0 minus 1. Gives me a negative 1 for an output. If I were to plug in 1, for example, I'd have what? 2 times 1 minus 1. That'd give me what? 2 minus 1. 1. F of 2. 2 times 2 minus 1. That would give me 4 minus 1, 3. And so on and so forth. Right. Etc. All right, let's do just another quick sequence. So maybe you studied sequences at some point in high school. It's often done in a pre-calculus high school type class. This one would be called an arithmetic sequence. If you notice, you're adding 2 term by term. So there's a common difference there, a common difference. They often call that D the common difference. It's 2. And basically the common difference is going to be the slope here when you're talking about a linear sequence. That's the common difference here. You're adding 2 each time to go from term to term. All right, let's do another sequence. F of n, so inputs are non-negative integers. F of n. Now let's actually call it a sub n. Let's call it a sub n rather than f of n. This is another notation you'll see. Sometimes you'll see it written like a sub n. Equals 5 multiplied by 2 to the n. And here n is greater than or equal to 0. So there's my specification. N has to be at least 0. So 0, 1, 2, 3, and so on. So let's go green. I'm looking at A1. A1 would be 5 times 2 to the 1. That's 5 times 2, or 10. A2, plug in 5 times 2 to the 2. It's going to be 5 times 4, 20. A3, be 5 times 2 to the 3. That's going to be 5 times 8, 40. And so on and so forth. Scroll a little. Etc. So if you notice what's happening, oh, I never did a to the 0. A sub 0 did I? Let me squeeze that one in. A sub 0. So 5 times 2 to the 0, it's going to be 5 times 1, or 5. So it looks like we started at 5, and then we doubled that, right? We doubled. Red here. So we multiplied by 2. And from 10 to 20, we doubled, multiplied by 2. And then we doubled from 20 to 40, we multiplied by 2. So this is called a geometric, because you have what's called a common ratio. A common ratio. A common ratio, that's sometimes called the D, the R. The R is the common ratio of 2. And it's basically the base of this exponential right here. You see the 2 to the n power? 2 to the n power. So the 5 out front is often called the initial term, right? This is called the initial term. That's the A0, right? A0 is 5. That's the initial term. And that 2 is what you're multiplying by each time. That's called the common ratio. Yeah. I'll just write that to the side. The common ratio. Ooh, crap. Common ratio. So common ratio. So you have to multiply to get to the next term. It's 2. So I mean, you deal with that when you're doing what's that called? Cal 2. You deal with geometric sequences, and you do geometric series. Back here in number 1, we had what's called the common difference. So to get from one term to the next, you had to add 2 every time. So that's your D. It's 2. All right, so in any case, those are what sequences kind of look like. We want to talk about a special type of sequence called a recursive sequence. So what is a recursive sequence? Definition. A sequence is defined recursively. So we're defining this. A sequence is defined recursively, provided the following criteria are satisfied. Number 1, initial terms of the sequence are given. Of the sequence, we've got to erase, are given. And number 2, a rule is given for forming successive terms from previous terms. Yeah, so let's look at an example of that. Example. So let f sub 0, or f of 0 rather, be 3, and f of n plus 1 equal minus 2, f of n for n greater than or equal to 0. So basically here we have our initial term, f of 0 is 3. And then to find further terms, you're going to use this recursive definition right here. So let's list terms up to f of 4. List terms up to f of 4. So we already have f of 0, right? Let's write f of 0 is 3. So if I want to find f of 1, by using my recursive definition here, f of 1 is going to be negative 2 times f of 0. So in other words, negative 2 times 3, which is negative 6. So there's my f of 1 term. Now let's find my f of 2 term. Again, if I use my recursive definition here, find f of 2, we're going to take negative 2 times f of 1. In other words, negative 2 times my previous term, which was negative 6. Negative 2 times negative 6 is positive 12. Okay, let's scroll a little. Find ourselves f of 3. F of 3, according to our recursive definition here, is going to be negative 2 times the previous term, f of 2. So in other words, negative 2 times 12, which is negative 24. And finally, we find f of 4. According to this recursive definition, f of 4 is going to be negative 2 times the previous term, f of 3. That's equal to negative 2 times negative 24, which is going to be positive 48. So those are the first, the terms f of 0 all the way up to f of 4.